Okay, we're going to do a little survey data with more attributes of a variable, just so you understand. Now, so this isn't, super long. We're going to essentially have the data here. But what's interesting is this asks the age-old, no pun intended, because we do it by age, perennial question, is it true when you're young, if you're not a liberal, you have no heart? And if you're old, if you're not conservative, you have no brain. So that's what we're going to see right here. So this is the age variable. Now, this is essentially whether you're a Democrat or Republican. So let's take a look. So we have age matrix. These are the different numbers I got from a poll. I believe it's CNN, fake news. But we're going to have to see. You have to play around with this. I do myself, right? So it's like, you don't know what's 63, 35, 51, 47, 44, 54. What are these numbers? These are percentages, but we're going to have to show you how to do it. So this is, the end row 4. Since we're going to have 4 groups of ages. So bear in mind now, look at the columns. These are going to be the 2 across. Oh, so even before I do that, so let's see what this creates. So what does this create? Age, that's the one. So here we have it, right? It's obviously got to be Democrat, Republican, and then these different ages because there's only 2 up here. So that's the key. If you want to do this kind of longer matrix, and you're going to see the names and everything, so it'll be clearer, but you do it like this, 63, 35, then 51, 47, 51, 47, then 44, 54, and then 43, 55. That's the percentage. But of what? Well, as I have here, I just go down here. These are the columns. Those go across. I don't know why I always forget that. So don't worry too much if you're, when you're doing a project or something, you're getting things wrong, because I always do. So you basically are seeing Democrat, Republican. So this is the Democrat. This is the Republican, right? Percentages. But percentage of what? Well, they found this through age. We can do different variables, like, say, for example, woman, male, different religions, white, African American, Latino. But I found this one to be kind of interesting. Notice it has to be in quotes with the names. So I'm just copying and pasting like this. But boom. So now it should pop up correctly. I actually did it wrong before, but don't tell anyone because I got the columns mixed up. So here you get it. So it's pretty good. 18 to 29, 63% identified as Republican, whereas 35% Republican. So a Democrat, Republican. So 30 to 44, that's the age range. 51% Democrat, 47. Then look at the numbers go down, but not that much here, but it does, begin to go up. So what the question is with this age, is there with the chi-square test? It's a test of independence. Are these independent from each other, or is there a correlation? Meaning, basically, is there a significant difference through, in this case, age group? So that's what we're doing with the chi-square test. So the chi-square test is actually not that difficult. We just stick it in age. Now, what makes this different from the other lectures is there's 1, 2, 3, 4. Before, we would only have male, female. But this is different. So you have to ask yourself, okay, age, is there? It doesn't seem to be as significant as I thought it would be, but there is a significance there. So it's under 0.05, which, as you know, I hope by this point, is statistically significant according to the algorithm we're using, obviously, degrees of freedom minus those. And 1, 2, 3, 4. I'm not that bright, -1. And then you have the R-squared. The higher, the better for your model, because that gives us our p-value, like the Z and the T test. So you basically are looking to see if this is significant. And this is essentially saying, yes, it's significant. I thought it was going to be, much more significant, but it doesn't seem to be. So that's a pretty interesting test. But the question is now which ones are significant and which ones aren't. This is the chi-square post-hoc test. That is the package this is from. So this is a really good post test, as I've done in class venues. So we just do the same thing, age as it comes up. And here you go. This is really good. So I really like it. Gives you the p-value. That's saying it's not significant at that age, right? Because it's, oh, it is. I'm sorry, 0.023. I'm actually used to, I don't know if it's the data sets or what, a more significant thing. That's barely significant, but it is. It's under 0.05. So it's significant. It's good. This is obviously not at 1. This is not. So it seems like the only big one is here, and the other ones are driving it down. That's interesting. I thought it would be very significant, and that's one of the things that's interesting about these variables is that you learn something from it. So this 18 to 29 is very, well, I wouldn't say very significant, but it seems to be the main group that is causing this to be significant according to the algorithm. And what you can see here is, oops, let me go up here. So you can see the whole thing. And let me show you my history. Ooh, that's another graph from earlier. Let me show you my history here. So in case you want to see it, there's a lot of history there. And so you basically are getting a somewhat, but not as significant. See, this is interesting. You know why? Because there's been movements to create a more conservative political science part of political science, because the argument is you get more conservative when you're older. And some have made the argument. I know a girl who worked in the Arizona legislature, and she said that the argument was, particularly to create more conservative programs at ASU, that the legislature want to give money because there was a significant difference between Republican and Democrat by age. And the reason why they weren't necessarily more Republican when they got older was because of liberal professors like me. But as I always say, I'm not liberal. I'm a communist. So that's a joke. But anyways, the point is that this might challenge it, which I did not know that, because this is the first time I ran the test, because it's not that significant as far as differences. There are differences, but according to this algorithm, they're not what we would call statistically significant when we look at 0.72. Now look at that 1. So we're not seeing it as different as we otherwise would see. And I find this to be extremely interesting, since this is kind of the argument that the older you get, the more conservative you get. Now, there might be truth to it in just the raw little numbers, but I think the problem with that, in a sense, is that, and I just ran this, I did not know the results, which this is what makes statistics extremely interesting, is that you basically are getting numbers that you wouldn't otherwise expect. And I think that that's one of the things. I mean, I'm a little maybe, I'm exaggerating a bit, people might think, but no, I thought that was going to be all extremely significant. In fact, if we do it without the Yates test, it's still significant without the Yates test. So is it the same? Yeah, I don't know why we're getting that when I do correct 4, and maybe if I go correct 2, are they the same? Yeah. Oh, I see, because of the amount of the length on that. So but anyways, that's basically significant, but not as much as I thought it would be. And of course, like I like to do, we have to plot that baby, see what happens. Here it is, and it came out relatively nice. I mean not nice, but then you can say, hey, yeah, there is difference, but not as much. Okay, so this is why we're seeing a big difference. The only difference really that's big is here. It's not as big as people would think, and that's before 18 to 29. And maybe they could argue, well, that's because here you're with these liberal professors or something. But it's a very interesting data set that I would definitely see. See if we can get some color on this, right? There's two. Let's go. What's the color of the Democrats? Say blue and green. All right. So it looks pretty good. Age, Democrat, Republican, and these are the age range. So we actually then were able to just simply graph it like that. So this is, as you can see, we found survey data. We ran it in chi-square. I'm surprised at the results. This is the only biggest difference. And then you get up, it gets kind of just more, let's say normalized, more like half and half. But look at, you do get that more Republican thing as you get older. Wow, as I get older, I better start voting for Kerry Lake. You know, I'm going to go to one of those protests where, you know, she won the election, but it was stolen by the pillow guy. The pillow guy stole the election. Wait, no, he's with Kerry Lake. And now he's fighting for Bolsonaro in Brazil. They only like when they lose, you know, they don't fight for if a Democrat loses, shouldn't they fight for that? I don't know. It's weird. But anyways, point is, very good plot, very good data set, not that difficult to do, and you can do it for a project or something else. Take care, everyone.